The Permian extinction wiped out nearly all life on Earth in less than 20,000 years. No natural process we know of can destroy so much, so fast. We assume humans are the first intelligent species to walk this planet. But what if that assumption is wrong? What if civilizations existed long before us, rising, thriving, and collapsing, leaving behind only faint traces buried in stone and ice? We're about to uncover carbon signatures that don't fit natural cycles, extinction events that look too precise to be random, and geological clues that suggest intelligence may have emerged before humanity. Like and subscribe, because this investigation challenges our deepest assumptions about Earth's history. Get ready. We begin. Deep in the soil of Gabon, Africa, scientists stumbled upon a discovery that rewrites what we think possible. Beneath billions of years of stone, they found uranium deposits that had once operated as nuclear reactors. Not crude, unstable experiments, but self-regulating, efficient systems that ran for hundreds of thousands of years without meltdown. These formations, known as the Oklo reactors, maintained precisely the 3% uranium-235 concentration needed for fission. Water flowed through as a natural coolant, regulating the reaction much like control rods do in modern power plants. The waste products, astonishingly, were contained in natural clay berries, preventing contamination for millions of years. At first glance, geologists argued this was a natural process. Unique atmospheric conditions, ancient groundwater cycles, and improbable geochemistry might have aligned perfectly. But here's the problem. This didn't happen once. It happened 17 times, across multiple reactor zones. The odds of this occurring by accident are vanishingly small, if intelligence had been at work. Some ancient species using nuclear power long before fish even walked onto land. Would we know? Probably not. 2 billion years is enough time for every artifact, every tool, every city to crumble and vanish. Only the isotopes would remain, locked inside stone like a message written in atoms. Mainstream science still leans toward natural explanations, but the precision of the Oklo reactors haunts researchers. How could nature design systems so close to our own nuclear engineering? And if a species once did harness this power, the bigger question is, what happened to them? Civilizations may not leave behind monuments. They may leave behind isotopes, nuclear echoes of a forgotten age. 6 to 6 million years ago, an asteroid ended the reign of the dinosaurs. But before that fiery impact, Earth was their kingdom for over 160 million years, far longer than humans have existed. Could some of them have risen to intelligence, building societies erased long before mammals took over? NASA scientist Gavin Schmidt once posed this thought experiment, dubbing it the Silurian hypothesis. He noted that if an industrial civilization had emerged tens of millions of years ago, finding evidence today would be nearly impossible. Fossilization is rare, urban environments don't preserve well, and Earth's surface is constantly recycled. Yet, consider the dinosaurs themselves. Many species had brains rivaling or exceeding those of modern mammals. Raptors displayed pack hunting strategies and communication. Herbivores coordinated vast migrations, suggesting advanced social behaviors. With 800 times the time humans have had, could evolution have nudged one lineage into tool use, agriculture, or even technology? If they did, nearly every physical trace is gone. Cities crumble within centuries. Metals corrode. Plastics degrade. Concrete dissolves. Over millions of years, nothing recognizable remains. What would need to look for are chemical signatures, unusual isotope ratios, mining scars, or abrupt ecological shifts. Intriguingly, Some carbon isotope spikes and extinction patterns don't match volcanic or asteroid events. They resemble the industrial fingerprints we ourselves are leaving behind. Massive carbon releases, heavy metal dispersals, and ecosystem collapse. Did dinosaurs build cities we'll never see? Probably not. But the lack of evidence doesn't mean proof of absence. It only highlights how fragile civilization truly is. If they rose, they fell, and Earth buried every sign of their existence. Imagine our world abandoned tomorrow. Skyscrapers collapse in centuries. Highways crack into rubble. Satellites fall, rust, and vanish. In just a few million years, almost nothing would remain. That's the terrifying part. If intelligent civilizations rose before us, their cities would already be gone. Geological processes erase everything. Tectonic plates swallow coastlines. Glacier grind landscapes flat. Volcanoes bury whole regions in molten stone. Even mountains crumble into dust. The fossil record teaches us this lesson well. Out of the billions of creatures that ever lived, only a fraction fossilized. The odds of preserving an artifact, let alone a city, are wise. Fossils favor bones, shells, and organisms near water. Tools and buildings don't get the same courtesy. So what would survive? Techno-signatures, subtle traces, like the chemical scars of smelting or altered mineral distributions from mining or long-lived pollutants embedded in sediment. Even agriculture leaves its mark, depleted nutrients in soil layers or nitrogen spikes from fertilizers that fossilize into stone. Today, we can already see humanity's permanent rock. Plastics are infiltrating rock layers. Concrete is becoming part of the geological record. Industrial chemicals are embedding themselves into sediments worldwide. These techno-fossils will last far longer than our monuments. If ancient civilizations existed, their legacy might not be monuments, but chemical whispers scattered in rocks and ice. The absence of visible ruins is exactly what we should expect over geological time. Civilization, no matter how advanced, doesn't build to last forever. It builds to disappear. Deep within Antarctic ice cores and ocean sediments, scientists have uncovered anomalies that shouldn't exist. Carbon isotope ratios appear that match fossil fuel burning, spikes of carbon-12 relative to carbon-13, occurring long before humans existed. These spikes are abrupt, global, and persistent for centuries before vanishing just as suddenly. They coincide with methane surges and heavy metal concentrations, hinting at industrial activity on a planetary scale. Natural explanations struggle to fit. Volcanic eruptions release carbon. Yes, but their isotopic fingerprints are different. Ocean currents can release stored carbon. But again, the isotope ratios don't match. Forest fires could contribute, but the sheer scale required, burning entire continents, strains plausibility. What's more, these anomalies line up with extinction pulses in the fossil record. Life collapsed as carbon flooded the atmosphere, then slowly recovered over thousands of years. This mirrors the damage we are currently inflicting: global warming, mass extinction, chemical pollution. Could these be echoes of civilizations before us, their industries collapsing into silence? Or are they evidence of natural processes we still don't understand? Either possibility is staggering. If natural, they reveal that Earth's climate system is capable of catastrophic upheaval without human interference. If artificial, they hint at predecessors who rose high enough to alter the planet, only to vanish, leaving only atomic fingerprints as their epitaph. The ice remembers what stone and metal forget, and the story it tells is unsettling. Earth has endured 5 major mass extinctions. The most devastating, the Permian extinction, wiped out 96% of marine life and 70% of land species. The cause? Officially, massive volcanism. But the timing is suspicious. Dating methods show the extinction unfolded in less than 20,000 years. In geological terms, that's the blink of an eye. Too fast for volcanic gases to spread gradually. Too sudden for normal ecological decline. The sequence of death is also strange. Deep-sea life died first, followed by shallow marine species, then land animals. Volcanic eruptions, however, should devastate the surface before the depths. The pattern doesn't fit. Carbon isotope records add more mystery. Instead of volcanic carbon, they suggest massive releases of stored organic carbon, forests, soils, ecosystems, burning and collapsing simultaneously across the planet. Other extinctions show similar oddities. The asteroid that killed the dinosaurs may not have been the sole trigger. Signs suggest ecosystems were already unraveling before the impact. Multiple extinction waves seem coordinated, as if something else was pushing life toward collapse. Some scientists whisper an unsettling idea. What if these weren't purely natural? Could ancient civilizations, through industry, geoengineering, or warfare, have destabilized the planet? We don't know, but we do know this. Civilizations, natural or artificial, can fall swiftly. And when they do, they take the world with them. Now we step from Earth to the stars. The galaxy should be full of civilizations. Hundreds of billions of stars. Billions of habitable planets. Time enough for life to evolve 1,000 times over. And yet, silence. This silence is the great filter. Somewhere along the path from chemistry to galactic empires, almost everyone fails. Maybe life itself is rare. Maybe intelligence is rarer. Or maybe civilizations destroy themselves just as they learn to reach the stars. The thought chills scientists, because if the great filter lies behind us, we are rare survivors, lucky to have made it this far. But if it lies ahead, we may be doomed, facing the same collapse that claimed countless others. Climate change, nuclear weapons, artificial intelligence, ecological collapse. Our threats mirror the very possibilities the great filter predicts. Humanity might be racing headlong into the same wall that stopped others before. The silence in space may not mean we are alone. It may mean the galaxy is a graveyard. Every civilization extinguished before it could broadcast, expand, or endure. The filter looms as both warning and riddle, and our survival may depend on solving it in time. Look beyond Earth. Mars once had oceans, rivers, and a thick atmosphere. Venus may have been a paradise of water and clouds before its runaway greenhouse turned it into hell. Both planets could have supported life, perhaps even civilizations. Mars holds dried riverbeds and clay deposits that suggest long-lasting lakes. Some formations resemble stromatolites, the layered microbial structures on Earth. Others show signs of organic chemistry that might have been shaped by biology. Venus is even more haunting. Climate models suggest it could have had oceans for nearly 2 billion years, longer than Earth has hosted complex life. If so, it may have nurtured not just microbes, but ecosystems, intelligence, maybe even civilizations. Then disaster struck. Mars lost its magnetic field and atmosphere. Venus spiraled into a runaway greenhouse, boiling its oceans and suffocating in carbon dioxide. If civilizations rose there, they fell to planetary collapse. And today, we find only hints. Anomalous gases in Venus's clouds, strange surface formations on Mars, and the endless question of what might lie buried beneath dust and lava. If Earth isn't the first cradle of intelligence in the solar system, then the red and morning stars may be its silent tombs. What lasts forever? Not our cities, not our monuments, not even our bones, but some things endure. Plastic is already embedding itself into rocks. Radioactive isotopes from nuclear testing mark a permanent line in sediments. Mining scars reshape geology. Our legacy will not be pyramids or skyscrapers, but techno-fossils, chemical and mineral signatures that shout, civilization was here. If others came before, this is what we should search for. Enriched uranium isotopes locked in ancient stone. Heavy metal deposits that defy natural explanation. Sudden carbon spikes in ice cores. Strange alloys in coal seams. These are the fossils of technology, not biology. Earth is a master of erasure, but not perfection. Some traces survive. Some whispers remain. And if we can learn to read them, we may yet discover we are not the first. But that truth cuts both ways. Because if others did rise, they all fell. And every trace of their greatness is now a ghost in stone. Humanity's future may hinge on whether we repeat their mistakes or learn from civilizations erased by time. If Earth has taught us anything, it's that civilizations, no matter how mighty, are fragile against the weight of time. From uranium anomalies locked in billion-year-old rocks, to carbon spikes frozen in ice, to mass extinctions that unfolded faster than nature should allow, the clues are there. They whisper that we may not be the first. But here's the sobering part. If intelligence has risen before, it has also fallen. Every species that might have mastered fire, farming, or even nuclear power was eventually silenced. Their monuments erased, their names forgotten, their worlds reset. Now it's our turn. Humanity has just begun its technological sprint, barely 2 centuries into the industrial age. Yet already, our fingerprints are all over the planet. Plastics in the oceans, isotopes in the soil, carbon in the skies. These will become our techno-fossils, our permanent mark on deep time. Whether future beings find them as warnings or epitaphs depends on what we do next. The great filter may still be ahead of us. Or maybe, just maybe, we have already beaten it. The only way to know is to survive long enough to leave more than just whispers in stone. So the question remains, will we become just another ghost civilization buried beneath Earth's endless recycling? Or will we be the first to step beyond this planet's graveyard and prove that intelligence can endure? That choice is ours to make. If you enjoyed this exploration into Earth's hidden histories, don't forget to like, share, and subscribe. The universe is full of mysteries and together, we'll keep uncovering them.